Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on errors. Due to road damage that heavy trucks cause, the Department of Transportation limits the mean weight of a particular type of truck to 19,000 pounds. All right, if the mean weight of the trucking company exceeds 19,000 pounds, additional fines and fees will be incurred. So it sounds like, hey, this is what you're going to claim. So the claim sounds like it's going to be 19,000. The alternative seems like it will be a greater than 19,000. The state police decided to check a random sample. Hey, that's great. That's our first condition, random sample. And our sample size in this case is 40. Of a large trucking company that has more than 4,700 trucks, this sounds like this is our population size, so N is less than 10%. The mean weight and standard deviation of the sample are 19,168 and 2,324. All right, so let's take a look at this. X bar, 19,168. And we have a sample mean of 2,324. Because we're working with a sample standard deviation of sample standard deviation, this makes it a t-test. Use an appropriate hypothesis test and a 5% level of significance. So here's our alpha, 5%. Determine whether or not the company should be fined. So with that said, this will be a t-test, as we said before. So there's our formula. T equals X bar minus mu S divided by the square root of N. When we went through this, we found the claim of 19,000. That's what we're not supposed to exceed, 19,000 pounds. All right, I don't have room to, I'll just write LBS. And 19,168 pounds was our sample mean. And our sample standard deviation is 2,324 pounds. And we have a sample size of 40. So we go ahead and substitute in the 19,000 for our population mean, the 19,168 for our sample mean, 2,324 for our sample standard deviation, and our sample size of 40. So let's go ahead and run this test. So this is going to be a stat test, t-test, and we have a mean of 19,000, a sample mean of 19,168, sample standard deviation of 2324, and a sample size of 40. And we want to know if it's greater than, and I should have said that, because we want to know if it exceeds, which is a greater than. And we end up getting a t value of 0.45 and a p value of 0.325. Well, that's a pretty large p values, and we don't reject. If the p is large, we keep it. So the p value is 0.3250, which is greater than our alpha of 500. 3,250 is definitely larger than 500, so our decision is to fail to reject. Well, let's go ahead and write down our hoe real quickly. All right, so we can talk about what we did. Well, the hoe was the mean equals 19,000 pounds. The ha, the mean was greater than 19,000 pounds. All right, so they want to know what type of error we could have committed. Well, we failed to reject. If you failed to reject, fail to type 2. All right, so the only type of error we could have made is a type 2. And just because it says, just because we could have doesn't mean we would. So anything that says was committed, that's wrong. All right, now it's type 2, fail to. So the type of error is a fail to. So what's the consequence? Well, we believed that it was 19,000. because we failed to reject it. We failed to reject it, so we believed this. So we believed the lying hoe. All right, so we believed the lying hoe, and this was the truth. So what that means is we believe that they were 19,000 pounds when they were actually greater than 19,000. So we failed to reject the null. So the only type of error that we could have committed is a type 2. In this case, we believe the truck's average weight was 19,000 when in fact that was false. We made an error and the truck weighed more than 19,000 pounds. The consequence is the trucking company will not adjust the weights of their trucks, all right, and they're not going to be fined. So they're going to getting away with things, okay? They're actually, we believe this, that was an error. It's actually greater than 19,000 pounds. All right. And they should have been fined, but we missed it. All right. I hope this helps. Look forward to seeing you on the next one. Thank you.